Hey there, I want to do another one of these limit scenarios. Last time we never reached our door because we could never reach it, but let's change it a little bit this time. Here's the new scenario. Same story, here you are after a long day of work, but this time um, instead of approaching your door, we're going to be approaching a little drop. So what we've got is we've got a giant pile of leaves down here, and we want to jump into that pile of leaves. And so it's the same story as before. Here we have 8 feet, and every minute, we're going to be walking half the distance to the cliff so that we can jump off into this nice pile of leaves we have here. So just like before, in the first minute, we walk 4 feet. In the second minute, we walk half of the remaining distance, which is 2 feet. Then half of that, which is 1 foot, and you know the story. Are we ever going to drop off the ledge into the leaves? And the answer is no. We're never going to drop off into the leaves for the same reason we're never going to reach the door. But this one's a little bit interesting because, once again, this space right here that we're approaching, that space right there is our limit. But here's an interesting question. What would actually happen if we were to stand on our limit? If we were to stand on the limit, we would fall into the pile of leaves. And so, in a way, even though the limit is approaching a value, it's not the value that we would be at if we were to actually stand at the limit. And so, I know that seems a little silly, but that's actually going to be important when it comes to certain types of functions. So in this case, the limit that I approached is not going to equal the value that I have right here. So let's look at another scenario. This time, this is what our little drawing looks like. Same idea. We're going to approach from the left, and this time we have a friend who's going to approach from the right. So this is the third type of scenario. Again, we're both 8 feet away, and the pile of leaves this time is in this little ditch, and we're going to try to jump into the little ditch, into the leaves. So first day we walk 4 feet, 2 feet, 1 feet, half a foot. We're never going to get there. 4 feet, 2 feet, 1 foot, half a foot. We're never going to get there. So one thing that's important to notice here is that I actually have 2 limits here. I have a limit as I approach from the left side, and I have a limit as I approach from the right side. So that's going to be an important idea. You can have a limit from either direction. And in this case, like with the ledge that we wanted to jump off, the limit from either side are going to equal this same value. But if we were actually to stand at the limit, we would fall into a different value, which would be the pile of leaves. So what should you take from this video? We know that a limit is a value that something approaches. We know that, and that's really, really important. You never get to the limit. This limit, because if you were to be at the limit, you would actually be at a different value. You'd be in the pile of leaves. And we also know that there are 2 kinds of limits. You can have a limit that approaches from the left and the limit that approaches from the right. So now that you kind of have the idea of what a limit is, let's actually apply it to something. Let's actually apply it to a function. See you in the next one.